Good morning to everybody in North America that's joining us for the webinar. Uh, we think that there will be some exciting new things that we'll be covering in the body of the webinar. I am Al Surratt. I have been involved with MainTegrity from the very outset almost 10 years ago, and have been involved in delivery of all of the uh, facilities that we're going to talk about this morning. I am also joined by my long-term colleague, Gary Euler, who has been responsible for installation in some of the world's largest customers. So again, good morning to North America. Good afternoon to all of those folks in Europe. Thanks for joining. I'll get right to it. We are going to have a little bit different webinar than what we've had before because the world of cybersecurity continues to change, and we have to change with it, taking advantage of technology advances of our own, but also technology advances in the rest of the mainframe ecosystem. Of those things, certainly the advent of the Z17, ZOS 3.2, and all of the features around AI in the current environment is very important. So we'll see in a minute how we fit into that ever better than we have before. So let me just start by saying what probably everybody knows already, which is that we are the epicenter of ransomware detection and removal for mainframes. We have recently been working with an extension into data exfiltration. Data breach, one of the most serious problems that can occur because there is no way back. There is no recovery. There is no way to get data back that has escaped mainframe. And that's happened in many more occasions than you might be aware of. There's also internal attacks where we do behavior monitoring to identify potential threats before they occur. And then, of course, ZOS authority, the number one threat in the environment, which also allows, if you get supervisory authority key 0, you are able to bypass security and bypass SMF. We'll talk about that in a minute when we get more involved with that. But we are also all about instantaneous response. And the first step in instantaneous response is always damage control. So we'll cover all that in a few minutes. So Gary, if you'd move on to the next slide, that'd be great. This is, we are actually going to show you how this works. Most of the time, we introduce what the product is going to do. But in actual fact, sometimes it's just better to see how it works real time, first person. So in this 2.5 minute video, you'll see how we can identify an encryption and thwart the attack. So if you would start the video for me, Gary, that'd be great.
This demo will show how MainTegrity, CSF, can detect and stop a data encryption attack on an IBM mainframe in real time. On the left side of the screen, we have an email inbox where alerts to the support team will appear. On the right, there's a TSO session representing how an attacker might operate. The attacker is about to submit a batch job that leverages hardware encryption to corrupt a number of files. Let's go ahead and submit that job. Now I'll switch over to SDSF to view the job's status in ZOS. As you can see, CSF has already detected the rogue encryption and automatically quiesced the process, stopping the attack in under 1 second. In many environments, detection can take hours. This is near instant. On the left, you'll notice a real-time alert has been delivered to the support team's inbox. Clicking on the alert opens CSF, confirming that the job has been suspended. Below, we can see the job name and the user who submitted it. A simple drill down reveals additional details: job name, job ID, and submitter credentials. Support staff can also view the datasets impacted by this attack. Here's a list of the affected datasets. Continuing the investigation, I can check whether this job has a legitimate business purpose. If it's a false alarm, I can simply resume the job. But in this case, it's unauthorized, so I'll cancel it. Switching back to my TSO session, you can see that the malicious job has indeed been canceled. Back in the support interface, since the job was canceled, I can now click into CSF Recovery Assist. By clicking here, CSF automatically generates the necessary recovery JCL behind the scenes. This JCL uses tools that restore at the dataset level, pulling from IBM safeguarded copies, Dell snapsets, or Hitachi snapshots, as well as conventional backups. Here we see the 5 datasets that were impacted. These are the ones I'll be restoring. All that support staff need to do is submit the recovery job. For demo purposes, I'll skip that step and cancel out. Once done, I mark the alert as resolved. Now the interface shows the incident status as resolved. This case is closed. By automatically suspending suspicious activity in real time, CSF gives support staff the breathing room to investigate thoroughly and take precise, controlled actions, while ensuring no additional damage occurs.
So that's exactly how this product works in real operation. So the same kind of capabilities, exactly what you just saw, are available for data exfiltration, are available for ZOS authority bypass, and security tampering, are available for ransomware removal and recovery. These are the kinds of attacks that are consistent with what has always happened in all of the mainframe attacks that we've analyzed. The key differentiators here is that we learn all about your ZOS system so that we can tell what is normal operation and what belongs. If you can tell what is normal, in the industry called a whitelist, then we can certainly detect anything that is abnormal. And this really avoids many false positives that plague other security products. But the really key difference here is that we can stop the damage, and we can stop it immediately. If our detection takes half a second, but it takes 30 minutes for a support staff to respond, then 30 more minutes of damage have occurred. If I rely on offloading all of that information to even the smartest AI tool, but not on the platform, it means that there's a significant delay. With the Z17 and trillions of instructions that can be executed, it is absolutely essential that you stop these things in milliseconds, which is exactly what we do. So if you'd be good enough to move on, Gar, I think we'll just kind of set the stage a little bit for those of you that kind of go, well, but mainframes really don't get attacked, do they? Well, in truth, in the old days, when they were walled off from everything, of course they didn't get attacked. But now, as there are more and more connections, TCP/IP and direct users that are outside the organization, or in fact, people that are inside the organization, whether they would be developers or internal users. These are all connections. Zero Trust has really focused us down on the problems can occur and attacks can take place from anywhere. But a very typical attack starts with a phishing campaign, they get a user ID, and MFA really helps in that environment. We recommend that everybody have MFA implemented. But once you're trusted, you're inside the walls. And now, often enough, if I can get my authorization elevated. We'll talk about that in a minute. Um, I, it it can be a very damaging attack. So these attacks typically originate in the network, which is why we have recently announced our product for data exfiltration. But more importantly, endpoint monitoring and the ability to monitor those actions in the network environment for even systems that are outside your control. So no agent required to go into the field. It allows us to identify things where actions have changed and behavior has changed of those specific devices. Key elements in this are multitudes of attachments. With our new capabilities, you'll know for the very first time what all of the systems that are attaching to your mainframe are and what applications they're using, and many parameters about their actual usage, which we store internally so that we can identify if behavior has changed. Ransomware as a service is a real threat in this environment, and so is AI. AI helps ransomers. It lowers the barriers of knowledge revolving around mainframe specific knowledge and allows even somebody with a rudimentary understanding of computers to actually launch a very effective um, attack on your environment. Sometimes these are state sponsored, but with more APIs all the time and more open source, there are more and more routes into the mainframe that are highly dangerous and have to be monitored. So most of those will be benign activity. We rule those out. We just look for the bad actors. Gary, if you'd move on, thanks. I've done a lot of research now into what the environment looks like and where have these attacks really taken place. And there have actually been quite a lot of attacks on mainframes and quite a lot of successful ones. When you see some of these attacks, 79 million records escaped, 190 million records uh, privileged, healthcare records escaped, 147 million financial records escaped. Where do you think they came from? Do you think they came from a Windows server? Well, in a way they did, but the Windows server probably had access and capability to interchange data with the mainframe where all of this stuff was really stored. So in many respects, it is the mainframe that was the culprit and ended up spilling these records into the hands of the attackers. But there are other kinds of attacks that are not specifically data exfiltration, and I'll get there in a minute. But I just want you to focus for a minute on the size of the cost and the upset. Many of these situations went on for years with litigation and all kinds of nasty activity taking place for one small issue that resulted in a big, long problem. Many of these problems were unrecognized for months because ZOS was never designed for ultimate security in a highly networked environment. Everybody talks about RACF, ACF2, top secret security, and they are absolutely essential. But at the same point, if you're a determined attacker, you can get authority, you can bypass selectively SMF recording and get privilege escalation done through the ESM tools, and then you're in a peck of problems, exactly like all of these sites encountered. So Gary, if you'd move on for me, thanks. What did we find when we looked at this? Well, we found out that often enough processes are unimplemented untested in production, and incomplete. You don't want to find that out when you're under attack. It says testing is important. It's why all the new compliance structures say you have to have pen testing. You have to have regular testing. You have to have recovery testing. Another piece is technology. ZOS has security gaps that have been there since it was built in its origins 50 years ago. SMF is slow, has to be offloaded. Oftentimes it waits for um, usage information to build up. Records may be 30 minutes late getting created in the first place. Then I have to offload it to some other place, which could be, Splunk, or could be TDZ, or could be some of the other analysis tools. That's a slow process. But if the detection step is missed, and we provide, far more detection in CSF than any other tool for the mainframe. If that is incomplete, well, then it doesn't matter how smart your AI is. It's not working on the most current information. And then there's people issues. At machine speed, humans are slow. If an encryption, which can run completely unauthorized, gets started against one of your databases, seconds matter. And if you're waiting for a human response, or you're even waiting for an automated response that depends on SMF or AI intelligence, it'll be too late, because they'll have trashed whatever they want on your system, and you will be left with a very long recovery at best, and perhaps many years of litigation. So we don't want that to happen. So Gary, if you'd move ahead for me. So what do? We took the best processes that existed, and we built them into our product in a way that's never been imagined before. So if you click again for me, Gary. That's where our technology comes in. File integrity monitoring, that was the first thing we did. And that and we extended that to look at behavioral changes where users or systems that are in the network change their behavior. They start looking at different data than they have looked at before. They start asking for different volumes or at a different rate, and they start to move some of that information out in an to exfiltrate your most sensitive data. How did they get access? Well, we're going to talk about that in a minute. But these are real problems, and that is what happened to many of those clients who encountered such immense problems in the billions of dollars, and still going up in a number of cases. So the other pieces that we put in place are real-time threat detection and real-time alerts. But since people are slow to respond, we need to stop the damage. It's kind of like going to the hospital. When you're bleeding, the first thing they do is they stop the bleeding, and then they ask you who shot you. But the notion that we would wait for minutes or hours or even days to get a reaction, a proper reaction, things have proceeded far too far by then. Immediate damage control with our suspend, resume, and countermeasures is unmatched in the industry. So Garrett, one more click. But that brings us to people. People make mistakes. We have a GUI that helps drive the entire investigation and recovery process, integrated from end to end. In-stream recovery guidance that is correct for your site. So an immediate attachment to who should I talk to, what DBA should I call, what phone number, what's the person's name, can all be embedded in that UI so that if somebody that's not very familiar with ZOS recovery knows who to call, knows where the contact information is, probably doesn't come up very often. So it's nice to be led through that process. Same thing is true in the recovery of the system. MainTegrity CSF will identify the ransomware to begin with and prevent it from getting in. But in the unlikely event that something slips through, we'll identify what has to be recovered, the compromised components, what backup they're on, and bring those components back, whether they're parameter sets, whether they're programs, whether they're JCL members, which in our experience are often left unprotected or not protected as well as they need to be. Those JCL libraries, very, very important. So that's the kind of thing that we can do. And we can also kick off the data recovery with data recovery tools that you already have in place so that people don't need to learn a lot of new things. So Gareth, if you would carry on. I'm just going to say ransomware is now a business and it's a multi-pronged attack. And every one of these things takes place in almost every attack now. So we're talking about embedding malware, embedding ransomware, multiple backdoors. Everybody knows about that. Compromise backups, overwrite a backup or render it unavailable in some manner, encrypt it, whatever the case may be. Those are the kinds of things that CSF looks after for you. However, the most common elements in every attack are we want to damage and compromise your ability to run your environment. So we encrypt a database or we encrypt a series of files or we get a low-level ID and we just encrypt things until that low-level ID has access to something that causes the system to fall over or whatever. That's what encryption can be, and it can be a rampant event. In ZOS, encryption runs completely unauthorized. It's just another problem program state. By the time SMF tells you that any encryption is taking place, it's 30 minutes down the line. We tell you immediately, and if it is in an encryption that you want to run in your environment, we will have learned about that during the automated discovery process, and we'll simply put out a note to file that says the encryption ran as expected. However, if it's not on that list of acceptable encryptions, then we send a real-time alert and you can take action immediately. In fact, we'll take action for you because we'll stop the damage. We'll isolate that one offending task and stop it dead in its tracks. Same thing is true of data exfiltration. Typically that happens just before the real attack mounts. And if you do not identify that data flows into the network have changed, or that a new IP address has attached, which is typically not visible in ZOS, if you can't do those things, you will always be subject to data exfiltration. So with that, I think I turn things over to you at this point, Gary, and you're going to talk to the exact features of the product.
Thanks, Al. I can't remember what you said at the beginning because my memory isn't what it used to be. But if any of you do have questions, if Al didn't mention this, you can put them in the chat and we'll run through them at the end. So the MainTegrity cybersecurity framework contains a lot of function. Originally, and it's about 8 or 9 years ago now, we went to market with file integrity monitoring. We primarily developed FIM Plus to meet the requirement for file integrity monitoring that exists in the payment card industry data security standard. However, FIM technology is also required if your organization wants to meet DORA standards or implement zero trust. The file integrity monitoring capability ensures that your system and application files stay in a trusted state. So we scan them periodically, and if a change is detected, we gather forensic information about the change, and we send notifications to the responders that these changes have occurred. We can also open an incident in Splunk or QRadar or ServiceNow if you want that to happen. The FIM component also auto detects many system libraries like your APF libraries, your parm libs, proc libs, and that kind of thing, so you can quickly protect your key data sets. The system has a mechanism so you can tell expected changes from unexpected changes, and this enables us to avoid raising events for expected changes and when they occur. Although we developed the ability to send emails and open incidents in third-party products when changes are detected for FIM Plus, these functions have become key enabling technology of the product we now call a cybersecurity framework. In 2023, we announced the availability of our early warning feature. With this feature, we provide the ability to detect and suspend tasks, which we saw earlier in the demo. And if a task exceeds thresholds for things like encryption, there's also thresholds for mass overwrites, mass deletions, and that kind of thing. We expanded the early warning offering last year to offer the detection of a number of other security issues, including the detection of the use of RACF commands and classes, and the detection of some really nefarious things like uh, increasing your authorization to be APF authorized, adding things like RACF oper status or special status to your user ID, or even doing user ID impersonations, that kind of thing. We can also detect and report on users who start snooping in places where they shouldn't go or where they don't normally go. This early warning function lets you watch what the people who have access are doing. So it's not about protecting you from getting access. It's about watching what the people are doing who actually have access. And this is really key to the next level of security that comes beyond RACF or ACF2 or top secret. A key differentiator for this early warning component is that it can take action immediately when an event occurs. You saw the suspension of the job in the demo earlier, but you can also do other things. You could cancel a user, you can issue operator commands, you can open incidents in Splunk, Top or QRadar, ServiceNow, those kinds of things. Where all of these kind of security function ideas came from, some of them were internally generated from our own development team, but we did speak with a number of well-known penetration testers when we were developing the list of vulnerabilities that we detect and alert on. Some of these penetration testers have our product installed on their own systems, and they tell us that they can't break in when we are installed. So if you're in Europe and you do have a need to comply with DORA, it's worth mentioning that DORA does require periodic third-party penetration tests. Clearly, if the penetration testers that we've been working with can't break into our system, having CSF installed will give you a leg up there. This fall, we're going to deliver data exfiltration detection, which Al talked about already. To me, this is the holy grail of cybersecurity function. Only if you can stop data exfiltration can you say that your data is truly secure. Once this function is delivered, we'll be able to detect the transmission of mainframe data over network links and stop it if it exceeds a client-defined threshold. In addition, we'll be able to detect if an unknown TCP/IP address is attempting to sign on to your network. This function is built on the cybersecurity framework, and that means that it will be able to whitelist known jobs and users and send emails on alerts as well as open incidents in third-party products. Basically, you get all of the supporting function that exists in the framework that the other components currently enjoy. Finally, we have a component that lets you control the releases of applications that are implemented into your production environment. It enables a separation of duties. It can compare releases of applications to show differences. It can even tell you after you've implemented a new release of an application on an LPAR if all of the components match what they are supposed to be. and if any components are back leveled, which level they came from. This feature's been around for a long time as well, since the beginning, I think, actually. As I touched on in the previous slide, the supporting functions in the framework are available to all of the individual components. This provides a robust set of capability that includes enabling you to suspend the tasks that exceed the thresholds. Suspending a suspicious task or user is a really useful function. It enables an investigation on a suspicious task to be undertaken when the task crosses a predefined threshold, knowing that it's not causing any extra damage or any additional damage to your environment. After the investigation concludes, you can cancel a job if it's malicious or resume it if it's benign. CSF does contain 3 human interfaces, but these human interfaces are all really derived from the one machine interface. The product CSF only supports one interface, and that's its RESTful API. We've exposed the functions of the product by using the REST API in the batch interface, the ISPF interface, and the browser interface. If you do happen to get an incident in an email, it will contain a link to an incident record in the browser interface. And this incident record will contain all of the forensic information that CSF has gathered about the incident. And it also provides the response capability if a response is required. CSF is a very powerful product and enables a level of control on your workload that ZOS sites have not had before. With this power comes responsibility. Care must be taken to not interfere with production work. To meet this requirement, CSF contains workload discovery capability, extensive whitelist capability, and the ability to exclude specific programs, job streams, and users from some of the security threshold features. For instance, CICS regularly impersonates other RACF users. One of the things that CSF detects is user ID impersonations. In CICS's case, this impersonation is required to perform its function. So we provide the capability to whitelist CICS so these types of alerts don't get generated. This is similar for the jobs in your batch job stream and other production components like IMS. The workload discovery capability will collect information about workloads running on an LPAR and gather a list of jobs and users which exceed the client-defined tolerance thresholds. This list can be reviewed and the discovered jobs added to a whitelist. If that job continues to conform to its usage characteristics, it won't generate an alert. However, if it does exceed a correct characteristic by more than a certain amount, and I think the default is 15%, but it's definitely settable, it will generate an alert. Since CSF is watching what your workload is doing, it will understand if any of your files have been damaged or compromised and which files those are. CSF contains the ability to take recovery JCL templates and customize them with the files that have been damaged and restore these from a previously taken backup. In addition, because we know when the files were damaged, we can advise you on which backups are the best candidates to restore from. Obviously, the ones that precede when the file was damaged are the valid candidates. We have interfaces to the immutable vendors, including IBM, Hitachi, and Dell. Because CSF contains an FIM component, we can add a final step to the recovery process, which creates a hash key and compares it to the key contained in our Vault repository. This can give you complete confidence that the file that was restored is the correct file.
So Garrett, just a second, just before we move on, could you go back just one slide there for a second? Because there was a question came in about safeguarded copies. We aren't going to go into that in great detail this morning, but in the case of a safeguarded copy, of course, it's created within the storage complex. That's true of Hitachi Vantara and Dell as well. But what we do, Gary mentioned that we have a REST API. Well, the REST API, we utilize the REST API to connect to the storage director on a IBM storage complex. And then we know all of the statistics about the safeguarded copies that are there. So since we have knowledge about when the problem occurred, and we have knowledge now about what safeguarded copies are available, it's very straightforward in the UI for you to find what's the right one, the recommended one, and then start that recovery with your standard recovery tools. And in fact, if you want to take that whole recovery process to a more granular level, there are surgical recovery tools that we interface with that we simply tell those tools, and one of them from Rocket and one of them from IBM and a number of others. You just specify the data set that you want to bring back, because most of the time these are not enterprise-wide recoveries that a cyber attack results in. It's a selective surgical recovery. So that whole process is very automated within CSF, and it's under the control of the support team, but with all of the information necessary to make the correct decisions. So even if a safeguarded copy is not created on time, we can alert you to that sort of information long before it causes a problem. But in a real crisis, we are welded to any of those immutable backups in a way that nobody else does. So back to you, Gare.
All righty. So what's next? We continue to innovate in the ZOS space, and this fall we've talked about it a little bit already. We're coming out with version 3.2 of CSF, and the biggest new feature is the data exfiltration detection capability. And it is going to be threshold based, and you will have access to whitelisting capability. And this is going to give you total control over where your data goes electronically. In addition, there's going to be a network discovery capability, and this will be able to tell you when a TCP/IP address is never signed on is attempting a sign on it. And the analysts in the industry are now calling this endpoint monitoring, open bracket, inboard, close bracket, to describe that function. So anyway, it's going to be there. We didn't really know that we were implementing that function when we started this, but they've defined a term that talks to it. We have added the ability to revoke users if you detect them doing things you don't like. We could always cancel a user, but we didn't revoke it. But now we've kind of realized, we've come to the realization that if you cancel a user, they could just sign on again. We might as well give you the ability to cancel them and include a revoke with that cancel. So that's coming. And there are some new features which are going to make implementation easier. We've included the ability to automatically load our SMF exits, and we use 3 of them at startup, and we've extensively streamlined and automated our product installation process. So there's a bunch of good stuff coming this fall, and we continue to innovate on the space, which there's not a lot of people doing that anymore these days. I'm going to turn it back over to Al now, and he's going to talk a little bit about integrating with AI.
Thanks, Gary. I don't want you to overlook what is coming with CSF 3.2. We understand the Z17 and MainTegrity CSF will run today on a Z17 on ZOS 3.2 in an environment that has AI and all kinds of other tools in the environment. So all of that was and is available kind of day one for the launch of these tools, because CSF is very consistent with the operating system and provides its support in a manner that is consistent with the overall security ecosystem. So very aware of other tools, not trying to do everything, just trying to fix a whole lot of problems that nobody else stepped up to. So, I mean, we talked a little bit about authority, and it's really important. In one customer site that we went into, one of the most severe problems you can have is an APF library that doesn't exist anymore. Now, you might wonder why that's a problem. Well, because the APF entry, the thing that says I can have an authorized program in this library. That parameter is still hanging around from many releases before. So the ability to get something into that, I actually create a new library of the same name and then put whatever authorization code I want in there, is a good example of how that works. But I want to bring this into focus because, a lot of people are thinking, wow, AI, artificial intelligence, well, that's going to know everything, and that's going to answer every security problem there is out there. Well, actually, we think it's terrific. We think it's terrific for slow-moving things. It's not terrific if you need an immediate answer right now, real time, milliseconds later. AI cannot work unless it has the right detection information to work on. And then it has a way of saying, we need to do a recovery here. I've looked at the suspicious activity. It is an attack. So in a way, CSF becomes, if you think about AI being a little bit of brains around an attack, really CSF is the arms and legs, because we have to do that detection to begin with. That's what we're really good at. Can we put it in a place like TDZ or Splunk, where a lot of that intelligence can be harnessed with all of the other activity in the network? Yes, of course we can do that. And then we do that in a real-time sense, so that those tools don't have to wait for SML. They don't have to wait for other data sources. They can start the analysis work when CSF gives you a real-time alert embedded in that database and kicks the entire activity off. So the point is, we can make those tools better by having better information in real time. But that key element, the absolutely critical piece of this, is that you stop the damage before you invoke, or at the same time as you send all that information to AI. That way, when AI comes back, I don't think we're giving AI total control here anytime soon. We're still going to want some decisions made by a human being. So we're going to suspend those activities, just the bad ones, not the whole processing complex, just the guys that are violators. We're going to suspend that. And by the time the likes of TDZ or Splunk or any of the other investigation tools come back to us, the damage has been stopped, and it is waiting for a human being to say, okay, I want to cancel this and we're moving into our automated recovery. Or no, we can just reinstate that because AI came back and said, oh, looks harmless. So we're just going to resume that and it'll take off from where it left off. So this is really important in overall value of CSF in the environment. Like always, it works within the ecosystem. The tools that you already have, it makes them better. So the enhanced ZOS detection, very important. All kinds of information that you can't get anywhere else. How can AI make an informed decision if it doesn't know that that RACF was bypassed or that SMF isn't recording a specific user ID? And these reactions are in milliseconds because we have damage control in place. Even if it takes a half an hour, the amount of damage is a few. These are the kinds of things, this is the way that we interact with AI. Direct access to the recovery capabilities is the resulting action. So this is really important. The value of this is all about zero trust. It's all about timely response. It's all about avoiding a problem or containing, if we can't avoid it in the first place, containing it at the absolute minimum pain point that we possibly can. So customer-specific recovery processes are really important. We actually can embed those within CSF so that whole recovery side of things can be automated. And as we always say, better security means better compliance. But better information means easier to audit, easier to prove, compliance with NIST and DORA because we built that in. Remember on that nice triangle? We built that in right at the ground level. But it really means we don't trust anything. Even a network device that has been in the network for a long time and it's been trustworthy, it suddenly starts to change its behavior or access different information, we're going to alert you and AI about that so that we can make a joint decision on what the right actions are. So Gara, if you'd move on. So that brings us to compliance. And almost all of the compliance tools have more or less the same pillars. We got to be able to identify, and we have to be able to protect, and we have to be able to detect, and we have to be able to respond, and we have to be able to recover. One more click for me, Gar. So what did we do? We looked at all those processes and we built these blue boxes of technology that implement those pillars. So how can we not be compliant? How is it that we're so good at compliance? Because we started with the compliance process and we built products that fill the gaps where other products had not taken that approach. So this is the reason why we can say our environment is better. One more click there. But the place where this still fails is when we go to say, look, we need to integrate with other tools. Gary talked about the REST API. We talked all kinds of tools that are in the network, on Windows, in ZOS. We bring that information together because we can interchange information with those tools. But we also have an end-to-end multi-vendor capable UI. And that means that when we raise an alert, a support member has to make exactly one click and they're placed in our UI, which will have all the information specific to that alert. And then they can take action depending on what that type of alert is. But it guides them through that whole process. It says, look here and do this. And, you know, that's customized at implementation time with customers in the field. But that UI is so powerful because it brings the human being who's got ultimate responsibility into contact with all of the tools that are necessary to make the decisions and necessary to do the recovery. So it works as an end-to-end tool. In that context, we provide all kinds of information that will satisfy any auditor about PCI, about NIST compliance, about DORA, integrate the pen testing, as Gary said, so far in our head-to-head battles with pen testers have won 0 and we've won 3. So, and we think, that's a pretty good place to be in. But the point is, it gives you the ability to, for the very first time, say ZOS is the most secure environment we have. More secure than the cloud, more secure than Windows, more secure than Linux, more secure because we have CSF, MainTegrity CSF, and the whole host of other security products that you already run. So, Gary, if you'd click one more time, we're kind of running out of things to say here pretty quick. But, you know, it is consistent with compliance because it started with compliance. But we extended that for encryption, for exfiltration, for the attack vectors. So these are the kinds of things that you need to think about in a holistic plan. So with that, I think we'll click one more time and then we'll go to questions and we can do some more demos and stuff like that if you like. We've got 10 minutes left in the hour. We've covered pretty much all of the content that we really wanted to. So hopefully that was a real step forward for you. We believe that this is an absolute game changer in terms of what's available for mainframe security. Gary, did we have, just before you do another demo, do you have any questions? Did you happen to check the chat box? Oh,
I can't actually see the chat box because
yeah.
I'm sharing my screen and I don't get to see the Zoom.
Oh, of course you can't.
Yeah.
Earlier statement was made, a recovery job could use safeguard. Yeah, we talked about that one. Okay, and so I don't have any more questions. If you've got any, I've got the chat box open, just send them in. But in deference to your time, we're going to do a couple more demos to show you that the encryption one is just one example.
I'm just going to sign on to our web interface. One of the things we didn't really talk too much about was file integrity monitoring. I just wanted to kind of maybe do a little demo of that, and I'll show you actually the recovery working and all the stuff that you get with the file integrity monitoring scan and a recovery. So I've got a collection of files. The program or the system works on collection of files, and so I've got a collection of files called GSE Mon1. And there's one in there called Gary.demo.control. I'm just going to go back into ZOS and edit a member in there. There's Gary.demo.control. If I don't know, I'll edit this one. And what do I do here? Actually, I'll save that. If I go back to so what I'm going to do now is I'm just going to run a scan on that collection of files, and I can do that from within the browser interface. I can also do it from batch or from ISPF, and I'm just going to do a quick scan. We didn't really talk about what types of scans we support, but a quick scan just really creates a key, the metadata portion of the key. The key's multi-part. There's a part of the key that's based on the contents of the data and part that's based on the metadata. I don't want to really go into it now, but we can detect most changes just doing a quick scan, which is the metadata piece. So I'm just going to go do that. It's been triggered. If I refresh this, you can see now that it's pending, and that just means it's run. And now we've detected that change in the file, and it's called it a mismatch. If I click on this, I'll get the information on this. There was a little bit of talk about uh, uh, immutable backups. This is from a long time ago. This is from last summer. We were doing some stuff working with Hitachi, and these are actually Hitachi snapsets. And what would be here is if these weren't so old, if there was some that were actually had occurred after the change was detected, we'd have a red X through them, just so you know. Anyway, we'll go back and we'll take a look at what we did here. So I changed that member. This is the member I changed. If I do a view on this, you can see there's the changes I made to the file, and they don't exist in the other version of the file and the correct version of the file. If I look at access list, this is actually the SMF data which pertains to this change. So it's the actual date and time that the change occurred. This is my user ID that I made the change with, and because it's TSO that made the changes, my job name is the same, and that's the IP address that I came in from. So if I was a responder and I got an email about this and I clicked on the email, I could come in here, and what a response protocol is just the instructions that you want a responder to follow to respond to this incident. So you can have those right in here. You can also have links to other documents. You can have documents just like this, but it is kind of up to you what you put in there. And you can have it different for different types of events and that kind of thing. So when you do get a change to a file, when you detect one, there's only one of two things can happen. Either the change is good and you want this change accepted, and so that the change file becomes the new normal and the key gets put in the vault, or you want to back it out. I'm just going to go ahead and back it out. And so this is, we talked about um, tailoring recovery JCL. That's what I've done here. And this is going to restore that one member in that file. It's also going to run a scan. It'll run a scan on the complete library in batch, and it'll just tell us that what we've done is got the file back to the way we want it. So I'm just going to go ahead and submit that. And if I go into scan history and I just wait till that runs. Oh, it's run already. So what happens then is it puts a little tick mark in that mismatched record, and the scan that I just showed you shows that the file is correct. Now it's back to the way that we wanted it and that kind of thing. So I just wanted to show you what the whole rigmarole going through a change detected and all that kind of stuff. In my Outlook, I'm sure that somewhere in here there is right there. So that's the email I got. It says that there was a validate event, there was a mismatch. It was in that collection of files and on this LPAR and that kind of thing. So we got the email and that stuff. So just
Okay,
wanted to show you that.
Gary, there
Yep.
was one question came in.
Yep.
Can you please show the side-by-side comparison again? Well, as it turns out, Gary made those changes, and the side-by-side comparison only works because there was a change that was put in that didn't match the trusted copy. So because it's a live demo, of course, when we go back in and say, do the comparison again, it would be comparing the original version, trusted version that was in the backup with the now trusted version that we recovered from the backup, so they would be the same. So it's a kind of a funny thing. We can't actually go back because it's a live demo. But thanks to Don for that question.
We are running, and that's the recovery job that just ended there. We are running out of time here, but if if you think about a set prog being kind of a nasty thing to do, you can add an APF library. If you want to detect that kind of thing, we just do that. I don't know what the threshold is, but if I just do this again, it doesn't matter that the syntax isn't right. I should detect that in my browser, and I'll just go to early morning and here, and so what time? 9:58. There's my user ID, and it says that I did a privilege. It says I did two of them, which I did, so it must be set to one. But there you go. So it just tells you that I at this time I ran a set prog. So I just wanted to show you that there's a lot of stuff here. There's a lot of function in this product, and we give you control of all of the stuff that's going on in your environment. So, and with that,
and this stuff, is not monitored elsewhere. So this is critical stuff to have. But Gary, let me just wrap up and say thank you very much to everybody that stayed on right to the end of the session here. I think this is real world beater stuff. And I think when you see it in your site, you'll agree.